Hey, so we've got this problem and it says simplify. Assume that all values represent positive real numbers. All right, so the only reason they put that in there is because if something was negative, you can't take the square root of a negative number. So that really doesn't tell us anything. We're just going to keep going like we normally do. All right, so the expression says y on the square root of 20 times y times x to the sixth plus x on the square root of 45 times y cubed times x to the fourth. All right, so I'm going to treat these as two separate problems. And then when I get to the bottom, I'll add them together and see what happens after that. So first, looking at this one, I'm going to kind of draw a little dashed line right here to keep them a little separate. Looking at this one, I can split up my square root using the property that says um, square root of a times b is equal to square root of a times square root of b. Right? So I can split it up into three square roots here. So I'm going to have y is equal y times square root of 20 times square root of y times square root of x to the sixth. All right. I'm going to look at the factors of 20, and I know that 20 factors into 4 times 5, and 4 is 2 squared. So I'm going to split this up again, and I'm going to have y on the square root of 2 squared times the square root of 5 times the square root of y. And this x to the sixth, I'm going to split it up into x squared times x squared times x squared. And I can do that because we had a property with exponents that says a to the b plus c is equal to a to the b times a to the c. So I'm kind of using this property to say I know that 6 is equal to 2 plus 2 plus 2. So I can split it up into x squared times x squared times x squared. That's kind of like the motivation as to why I wanted to do it like that. So I can again split up my square root again, and I'm going to get times square root of x squared times square root of x squared times square root of x squared. All right. And then I know that if I have the square root of something squared, I'm going to get back the something. So if I had like the square root of a squared, this is a. So I'm going to get y. Square root of 2 squared is 2. Square root of 5, the 5 isn't squared, so I have to leave it alone. I just have square root of 5. Same with the y. I just have square root of y. Then all of these x squareds are being taken the square root of. So we're going to have x times x times x. And I'm going to move everything to the front. So I'm going to have y times 2, or I'm going to do 2y times x cubed. X times x times x is x cubed on the square root of 5 times the square root of y. Then I'm going to use the property that I used up here, but I'm going to kind of use it backwards. I have square root of 5 times square root of y. So I'm going to say that that is 2y times x cubed on the square root of 5y. And that's going to be for that side of the plus sign. Now I have to do the same thing for the other side. I'm going to use this first property again and split it up. So I'm going to have x times the square root of 45 times the square root of y cubed times the square root of x to the fourth. All right. I know that 45 factors into 9 times 5, and 9 is 3 squared. So I can rewrite that as x on the square root of 3 squared times 5. This y cubed, I'm going to write this as y squared times y to the 1. And this x to the fourth, I'm going to write as x squared times x squared. I can do that because of this property right here, like we did with the x to the sixth. I'm kind of circling it in big red right here, this red dot. I use that property again right here that we're just doing with this x squareds and these y's. So I get square root of y squared times y to the 1 and the square root of x squared times x squared. And I can use the property that I can split up my square roots again to split up all of these. And I'm going to get x on the square root of 3 squared times the square root of 5 times the square root of y squared times the square root of y times the square root of x squared times the square root of x squared. And then I'm going to use the property over here that if we have something squared and we take the square root of it, we get back the something. So all of these square roots are going to start canceling out. So we have x times 3. This square root of 5, the 5 isn't squared, so I have to keep it in the square root. Y squared, the square root of y squared is y. This square root of y to the 1 isn't squared, so I have to keep it the same. So it's just the square root of y. And then these square root of x squareds are just going to be times x times x. And like I did before, I'm going to bring everything to the front. And I'm going to combine like terms. So I have 3 times, I have 1, 2, 3 x's, so x cubed, and I have 1 y. And then I'm going to have square root of 5 times square root of y. All right. So then I'm going to do the same thing like I did over here, and I'm going to write square root of 5 times square root of y as square root of 5y. All right. Now that I've done, that was the meat of the problem. I'm going to write them together with that addition. So we have 2y x cubed square root of 5y plus 3x cubed y square root of 5y. And we have the same variables here. We have 1y, we have x cubed, and we have square root of 5y. That means that I can pull out those, and I can pull them out, and I'm going to have y times x cubed square root of 5y times 2 plus 3. And I can distribute these to both of these, and I would get back this expression that I'm putting a cloud around. I can distribute and get back, so they're equal. 2 plus 3 is 5, so I get 5y x cubed square root of 5y. And that is my final answer.